Okay. So, a little context here without going too far into it. Let me just pull up. So what we're building here is called UV CycleGAN, and there are public papers and a poster that I put on my ResearchGate recently about this, if you're curious. But instead of going through all that, because that's not what this is intended to be, I'll just go through this real quick. Essentially, what UV CycleGAN is a domain translation model. So domain translation is just taking from one type of data or one domain of data to another. And our different domains here are called remote and lab. Remote being low resolution data acquired from a spacecraft remotely, and lab being something like high resolution data acquired in a lab instrument. You know, lab data tends to be really pristine. It tends to be really high resolution, really clean, not a lot of interference. Remote data from spacecraft tends to have interference from atmosphere, or the instrument response function is more significant. There's more significant, less significant bandpass, I guess you could say. All of those factors kind of folding into one model that will learn to take data from one domain and rebuild it in the other. So let's say you have a situation where you have a bunch of samples of something in the lab domain. You know what it looks like in the lab, but you don't know what it looks like in the context of some other instrument. But you do know what other things look like in that context. Well, you can train a model to translate between them. So like translating translating languages and doing something like image translation. I think I showed you guys this earlier. The, horse to zebra, zebra to horse. This is the CycleGAN. But anyway, so I'm building up this model again to make a more organized code base that we can publish. And we've gone back and forth between TensorFlow and PyTorch. And I've landed on TensorFlow for this version at least. And in the previous version of TensorFlow, I've had this issue where the identity loss, which you see here, is essentially you take the, if we're talking going, let's say here, right? You're talking going from the real lab domain to the remote domain, so remote to lab. Well, identity loss is saying if you take the target domain and put it in the input, it shouldn't change it because it's already in that state, right? So if you're going from A to B and it's already in B, that A to B generator shouldn't change things. So that identity loss hinges on the ability in at least the TensorFlow model that we have set up. That's pretty simple. Well, not simple, but like the functionality is simple. It's trying to take two domains of different shapes, right? So it's saying it's taking something that's 16 bands, right? So if we use this example here, right? It's taking something that's 16 bands and putting it into a generator function that's expecting 156 bands. And this is kind of problematic because these are normally set up to, effectively compare the input and the output. So if it's expecting 156 bands and it gets 16, the actual shape of that function, the shape that's going into that function is problematic. And I need to look into this more because I'm not quite sure. Maybe it'll help to put this out there. But effectively, what you need to be able to do is then remove the identity loss for these situations, right? But then are you really truly running a CycleGAN? So I didn't have this problem last time, I think partially because I set it up incorrectly and I had my identity loss essentially be the same as the cycle consistency loss, just in the opposite end. And so you essentially had just two not competing, but reinforcing loss functions. It's not necessary. It wasn't representative of what we could get with CycleGAN. And, maybe this is part of why we had so much trouble overfitting to particular reflectance values. Maybe not, but it's worth making sure that we actually do this correct. It's just, here's the question, right? How do you do identity loss on two domains of different shapes? And this is where I'm like, oh, fuck, do we need to go to PyTorch? Because, PyTorch is just a lot more versatile, but I had a lot of trouble with, getting that built up in a comfy way. But I don't know. I'll do some research. The other thing is we could use like feature extraction, right? We could do, spectral accuracy or something like that. There's a lot of ways that we could remove the dimensionality from the equation there. But all of those are going to be like doing a derivative of what the original data is. Ideally, we work within raw format. But I don't know. How do you do identity loss between two things of different shape? If you do identity loss between two images, presumably, you can scale them. But you can't exactly. Could be scale spectra. I mean, if we just took it in, but then you're basically just doing a averaging, right? You're a band averaging according to the instrument domain. So you're really cutting a lot of the, yeah, I mean, if we tried to do that, then you're doing a band averaging for that instrument domain, and you're effectively doing the really dumb, simple way of what we're trying to make work with a CycleGAN. So I feel like that kind of bypasses things. I don't know, maybe that's worth looking into. So what I'm thinking is we take the real equivalent, when we put it in the lab remote generator, we just convert it to the lab domain but then... take every band and segment it until it matches the remote. Okay, man, I might be cooking with that. Let me write that down. Band averaging. Here's what I'm thinking. Like, although it would be a dumb, simple way to bypass the problem, as long as we make the identity loss like a relatively low weight. The benefit is that the long range feature matching, which is relevant to our abundance issue, could benefit from. All right, I don't know. I'll think through it. I just wanted to get something out there. Thanks.